Welcome to the final installment of Fidget Spinner series. And if you don't know what I'm talking about, or this is like the first video you're watching in the series, you can click on my face or in the description below for a intro video on what this whole thing's about and the physics of what a fidget spinner does. And if this isn't your first video, without further ado, let me present to you the floating merry-go-round. And here's how it works. Or, well, let me give you a bit of background first. I really like this experiment because it's basically a replication of the bicycle gyroscope, which is something I've seen in physics class. I never really got to understand it until I demonstrated it with a fidget spinner. So, here's the clip. And so, back to it. Here's how you can do the exact same demo with a fidget spinner. You probably have a fidget spinner at home. All you gotta do is tape like a piece of string so that the string comes up from like the middle of the fidget spinner. Tape it so that when you hold it, it kind of like is flat-ish. You know what I mean? And so, here's how the experiment works. You're gonna hold the fidget spinner vertical and the string up, and what's gonna happen? Bam, it goes flat, right? They're just like rotation thing going on because the string is pulling up, the fidget spinner is pulling down, and it falls. Okay. Here's the cool thing. All right, the string's gonna go to the bottom. I'm gonna spin the fidget spinner. Right. I'm gonna pull the string up vertical, and the thing should fall, but it doesn't. It actually moves in a circular gyroscope-ish fashion, but it's kind of weird, right? Like, shouldn't it just, when it stops, doesn't it just fall? Why doesn't it fall instantly? And so I'm going to explain why using these color-coded circles on the fidget spinner, and this thing, I call it a force direction vector thing. So basically, if I'm pushing this way, this arrow is a representation of it, okay? So here's how it works, and I think it's actually pretty cool. So, you got the string here. Just follow the pink circle, okay? The string is pulling up, and the fidget spinner has mass that's pulling down. So in terms of the arrow, this is pointing up with the string, right? I don't have enough hands. Pointing up here, pointing down there, and pointing up here and down there is the same as pointing this and that way, because it's basically just a twisting force. That's why this thing is twisting, alright? But here's the funky part, okay? When the string points a force up and this goes down, it's as if this pink thing is going to that direction, the bottom of it's going that direction. That's why it twists, as I said before. So the force direction is this way, right? And so it should twist down. But the thing is as this rotates, goes to the bottom, there's another force vector that also pushes out. And so instead of it having continuous up here and it's pushing down, it goes up here and then switches down and pushes again, and then up and down, and it cancels out. It's kind of like experiment number 2. And so this happens not only for the pink, but also for the blue and the orange. So as the blue thing pushes that way and it spins to the bottom, it pushes that way. Same if it's on like this side and then it spins to the other side. And so basically, as that fidget spinner is like rotating along the axis, it's not falling because there are force vectors that like cancel it out so it doesn't rotate. Like if I'm here and like I push on the top of my head's gonna go down, but if I'm like pushing the top and the bottom, it's just gonna like go. It's not gonna actually fall down. So I hope that makes sense, and that's my explanation of the bicycle gyroscope. If you want to look more into it, you can Google it. And so you're thinking, Michael, why is learning this physics so important? Why do I need to know it? And the answer is, you don't. You don't need to know it, but it's cool because it talks about how rockets like stabilize themselves inside because they have these things called gyroscopes. Cool stuff. You can search it up, or I'll maybe put some links in the description below of more info into it. But basically, physics is the best way, I believe, we can physically see how things react, act, in maybe ways that we don't expect, and explain it. So thank you for following me through the series. If you have watched all 4 videos, I commend you because that is an impressive feat. And let me know in the comments below what you think of it. And I hope to see you soon. Do you guys like these types of videos? If you do, let me know. And peace out.